All right, question 2 for the Unit 4 review. A calculator generates a random sequence of digits. A sample of 200 digits is randomly selected from the first 100,000 digits of the sequence. The following table gives the number of times each digit occurs in this sample. So when we're looking at this table, top part is just telling us the digits that it is going to land. So it's just a label. And then our second part of the table is our frequency. How many times did it land or occur during that time? It is claimed that all digits have the same probability of appearing in the sequence. Automatically, if you see frequency on your table, it is going to be a goodness of fit test. That is definitely a key significance for a goodness of fit test. So we are using a goodness of fit test here. And I see a lot of people getting this wrong or mistakenly putting it in their calculator. The top row is not going to be your list one. Like I said, the digit is just giving us a label of when or what digit it lands on. Frequency, that is what we're observing, that's going to go in our list one. So the list one is our frequency, which is our observed. And again, I'm just going to state that this is our observed data. And we need to figure out what is going to be our expected data. In order to do that, we are trying to say that it's going to have the same likelihood, the same probability of it landing on any digit. So we have a total of 200 digits, and our expected, so I'm going to kind of put it down here for the B part. Our expected would be taking that 200 and then dividing it by how many digits could it land on. And there are 10 digits: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's including 0. So our likelihood of it landing on any of the digits, if it was the same probability, would be 20 times for each number. So now we're going to state our null and our alternative. We're going back to A. Our null hypothesis would be, and again, if you cannot think of a good null hypothesis based off of the scenario, you could just say that the data has a uniform distribution. Uniform distribution. Again, Glitchy's website. And then our alternative in this case would be it's not. And yes, you have to write all of the words on your test. The data does not have oh my goodness, I should just go back to my other app that I was using to write because this is very glitchy. Okay, so here we go. So we did A, we did B, and now we need to conduct a goodness of fit test at a 5% significance level. So we're going to go ahead and do that. When you're putting a goodness of fit test, you are going to, let me just move my calculator. Oopies. Let me minimize this. What is happening here? Oopies. There you go. Nope. There. Nope. 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 My goodness. Here we go. What is happening? All right. There it is. I'm going to make this a little smaller. Okay. We are going to go to our list. We're going to edit our list, and we're going to enter our frequency that we have. So this is 17, 21, 15, 19, 25, 27, 19, 23, 18, and our last number is 16. This is what we observed. We observed that each digit landed on those numbers, and we're expecting it to have an evenly same probability for them. So now we're just going to place 20 straight down because that's how even it would be. And that one's a 0. All right, now you're going to press Stat, go to your test, go upwards to the GOF, which is the goodness of fit, and you are expected to know your degrees of freedom. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 categories here. So you're going to take that 10 minus 1, leaving you a 9 of degree of freedom. Calculate that, and you get your chi-square test. Chi-square value is 7. Your p-value is 0.637. And we are going to compare that with our significance level of 5%. So now let's write a conclusion. Here is my conclusion. Since p equals 0.637 and it is greater than 0.05, we accept the null. So when we're accepting the null, the data has a uniform distribution. So what does that mean in context? That means that the digits are going to appear evenly throughout the sequence or has the same probability to appear in the sequence.